Hello viewers, good day and you're welcome to my YouTube channel. Please, if this is your first time of tuning in, please consider subscribing. Alright, in today's lesson, we're going to be looking at mathematics under the concept of sets. But precisely, we're going to be looking at representation of sets. In this lesson, we are going to be understanding that there are two ways in which sets can be represented, which are the listing method and the set builder method. So these are the two ways in which we can represent sets. So this video generally is going to be more like practice problems to see how we can represent sets in these two notations, that is listing and set builder method. So I have a series of questions here. The first question says, write the set of the first 10 natural numbers in both notations. Write the set of the first 10 natural numbers in both notations. So first, we have to understand something very important before we move on. So this is a number line, for instance, and on a number line, there are numbers that ranges from 0 here. From 0 towards the right is 1, 2, 3, 4, 5, 6, and so on. And again, from the same 0 towards the left are -1, -2, -3, -4, and so on. Alright, so this is a simple representation of a number line. Now, on a number line like this, all these numbers, of course, from 0 here towards the right, it continues. No wonder I have dot, dot, dot like this. And again, from 0 here towards the left, it continues. Hence, I have dot, dot, dot like this. Now, I want you to know that all the numbers on the number line, including the positive part and the negative part, even 0 itself, all of these numbers are collectively known as integers, such that from 0 towards the right are called positive integers, and from -1 towards the left are called negative integers. Again, talking about natural numbers, now I also want you to understand that from 1 towards the right, from this positive 1 actually towards the right are called natural numbers. Alright, from 1 towards the right are called natural numbers. And now, from 0 towards the right are called whole numbers. Very important. And of course, all the numbers, including positive part, 0, negative part, are called integers. Integers. Alright, so this is it. So now, set of integers means all the numbers on a number line. Set of natural numbers means all the numbers towards the positive part, excluding the 0. And whole numbers includes all the positive part, including 0. Hence, 0 is a whole number, but 0 is not a natural number. Now, back to the question that says that we should write the set of the first 10 natural numbers in both notation. So, we start number 1. So let that set be called set A, such that it is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is the set of the first 10 natural numbers. Since we see that natural numbers ranges from 1 towards the positive infinity, excluding the 0. So this is the set of the first 10 natural numbers. Now, this is actually the notation of this set in listing method. Now, for us to represent this same set in set builder method, so look at what this information means. This is the set builder notation of this set. So these two things are the same. This is the listing method. This is the set builder method. In the set builder method, it's trying to say that A is set of X such that, of course, this slash means such that, now X. So let me read it aloud again. A is set of X such that X is an element of natural numbers. Now, this is the condition. This part now is actually trying to tell us the natural numbers, how many of them in question. Alright, so this part is trying to tell us that X is greater than or equal to 1, and the same X is now less than or equal to 10. Now, in mathematics, whenever we see less than, whenever we see now, this thing now, this part can actually be read as, 1 is less than or equal to X, or X is greater than or equal to 1. So, of course, these are the elements called X. So x is obviously greater than or equal to 1, because now when we say or equal to, means that the first number must be included. So assuming that what I have here is x is greater than 1, like if there is no or equal to, means that 1 will not be included. So this part now, this part of this set builder method tells us the range of the natural numbers. But of course, this part has already told us that whatever thing s is a natural number. And this part is trying to tell us the limit of the natural number. And this part again is also trying to tell us that it is not all the natural numbers that are in set A. Very, very important we understand that. So please take a note on that. I'm going to wrap it up and tackle the second one. Okay, so question 2 says, write the set of whole numbers that is less than 10 in both notation. Write the set of whole numbers that is less than 10 in both notation. So let the set of whole number, let me call it set B. Now, set of whole numbers that is less than 10. Whole numbers, like I said, whole numbers includes from 0 towards the positive infinity. Whole number that is less than 10, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I'll stop there because it says that is less than 10. So now, of course, if I included 10, I've already ruined what is being said, because it says set of whole number that is less than 10. So 0 is a whole number, so 0 is going to be included. So this is actually what we are asked to write. Of course, looking at it in the listing method, it appears so simple. But let us now put it in a set builder notation. So putting it in a set builder notation, set B is going to be set of x such that x is an element of whole number. So W is used in this case to represent whole number. Now, and it's not just enough. It is not all whole numbers that are in this set B. So we're going to put the next condition or the next statement that's a kind of illustrates what we are trying to do in this set builder method. Therefore, we're going to say that, and now the next part is going to be the condition actually. Therefore, we're going to say that 0 is less than or equal to x, and x is less than or equal to 9. So we can as well reread this last part of this statement as x is greater than or equal to 0 and x is less than or equal to 9. So this or equal to means that 0 is inclusive, and this or equal to this part means that 9 is also inclusive. So this is the listing method of this question 2, and this is the set builder method of this question 2 again. Okay, that is it for question 2. Now for question 3, let us see question 3 very quickly, so you can take the note of this one. Now in question 3 it says set of integers, that is, write the set of integers that is greater than 4 but less than or equal to 5. Set of integer, let it be called C, that is greater than 4. That means greater than 4 means that it's going to start from -3. Sorry, that is greater than -4 rather, so it's going to start -3 but less than or equal to 5. So -3, -2, -1, 0, 1, 2, 3, 4, 5. So we're going to include 5 because it says but less than or equal to 5 in both notations. So this is the set. This is the set now in listing method for question 3. Now, again, in the set builder notation, is going to be this. It's going to be that set C is set of x such that x is an element of integer. So Z is used to represent integers. Element of integer. Now, and of course, now for us now to give the next condition on this part now is going to tell us the range of this. And it's going to be that -3 is less than or equal to x such that x is less than or equal to 5. Very, very important. Very, very, very important. Okay, so this is the listing method of that set. This is the set builder method of that set. Let me read the set builder method once again. Say that set x, it means that C is set of x such that x is an element of integer. Very, very important. And this part is trying to tell us the range of this set in this listing method. It's trying to tell us that x actually ranges from -3 to +5. So of course we have that x, because remember in the question it says that is greater than, sorry, yeah, it says that it is greater than 4. So since it says that it's greater than 4, means that 4 is not going to be part of here. But if the set has said that, if it has said that it is greater than or equal to 4, it means that we are going to include 4. But since it did not say or equal to 4, 4 is not going to be included. Okay, so this is the listing and this is the set builder method. Okay, let me quickly do the next one. I think we will do it over here. The next question should be question 4. Question 4 says, write the set of positive even numbers that is less than 15 in both notation. Let me read it again. Set of positive even numbers that is less than 15. Okay, let me call it set D. Let it be set D. Set of positive even numbers. So it therefore means that we can actually as well have negative even numbers. The same way even numbers are 2, 4, 6, 8, 10, and so on. Those ones are now positive even numbers. You can as well have negative even numbers, which are -2, -4, -6, -8, -10, -12, -14, and so on and so forth. But this question is very specific enough to telling us that it is set of positive even numbers, but it has to be less than 15. Therefore, it's going to be 2, 4, 6, 8, 10, 12, 14, and here. Alright, so because they said it is less than 15, so these are positive even numbers, so 15 is not going to be included. Of course, 15 is an odd number, but had it been the question says set of positive even numbers that is less than 16, we still would have ended here. Alright, okay, so this is it in listing method. What about in the set builder notation? What are we going to have? We're going to say that now in this case we're going to say that D is set of 2x such that x is an element of natural numbers. Very, very important. So what this part now means that now, of course, we know what natural numbers are. Natural numbers are those numbers on the number line. I mean, those numbers on the positive part of the number line, excluding the 0. Okay, so now for us now to put this in perspective, we're going to say that D is set of 2x such that x is an element of natural number. For the next part now, we're going to put the condition. Alright, the condition on this part means that the range. So we're going to say that 2 is less than or equal to x, and x is less than or equal to 14. So this is it in the set builder notation. Okay, and of course another way we can represent it, because this 2 in front now is a kind of trying to cause problem, but let me also represent this again. So set D can as well, now in the set builder notation again, can as well be written as x such that x is even numbers, is equal to even numbers, and we are going to put the condition even numbers such that we are going to have that it is 2 so that it is 2 less than or equal to x less than or equal to 14. I think there's a, sorry, I made a mistake over here. This is supposed to be 1, this one is supposed to be 7. Okay, look at what it means. So we see that x is an element of natural number. So we've got now in the first condition I've gave, this and this, they are the same way. These two things are the set builder notation of this listing method. But in this first set builder notation, it's trying to say that this is set of 2x such that x is a natural number. And now whatever thing, now it means that x is going to range from 1 to 7. Meaning that if I take s to be 1 and put it in here, I'm going to have 2, which is this 2 here. If I take, of course, ranging from 1 to 7, if I take s to be 2, because 2 is also in this part now, 2 is also found in this part. So if I take s to be 2 and plug it in here, I'm going to have 4. Take s to be 3, put it in here, I'm going to have 6. Take s to be 7, put it in here, I'm going to have 14. So this is actually what it should be here. Now, but on this part, if I see that D is set of S such that S is even numbers, now those even numbers are actually going to range from 2 to 14. So it's either this or this, so whichever one you wish to. But it will be wrong if the condition on this part is equal to this, so it won't be right at all. Very, very important. So this is it about question 4. Now the next question I have on the list here is question 5. Question 5 says set of odd numbers that is greater than or equal to -7 but less than 5. Okay, let me clean up this. So set of odd numbers. So let me just use maybe let me use the symbol E to represent this set of odd numbers that we are talking about here. Okay, set of odd numbers that is greater than or equal to 7 but less than 5. Greater than or equal to 7 means that 7 is going to be included, so -7 is going to be included. So greater than or equal to 7 means from -7 to 5. But it says greater than or equal to 7 but less than 5. It did not say less than or equal to 5. It means that 5 is not going to be included. So -7 is going to begin the set, but 5 is not going to end the set. So -7 minus 5 minus 3 minus 1. Of course, next one should be 1. Next one should be 3. Next one should be 5. But since 5 is not going to be included, we end the set here. Remember, this is set of, now talking about number lines, now this is more like the number line I've already told you. Now, and of course, if you check on the number lines, we have odd numbers there, we also have even numbers. But now, talking about the odd numbers, we can have positive odd numbers and negative odd numbers. And this set says that it is set of odd numbers that ranges from -7 to. Now, this is nothing but the listing method of this set of odd numbers. Therefore, putting this now in the set builder notation, we are going to say that set of x such that x is equal to odd numbers. And saying that it is equal to odd numbers, we are going to put the condition. Putting the condition or maybe the range of this odd number, we are going to say that it is -7 less than or equal to x less than or equal to 3. This is the first way we can represent it. Or we can say that set E is set of x such that x is odd numbers ranging from -7 less than or equal to x less than 5. Now notice that I said less than 5, not put or equal to. Now if I had put or equal to here, it means that 5 is included. But 5, since 5 is not included, there's no need of putting or equal to. Very, very important. And of course, the next way we can represent this is this, that E, which is this set of odd numbers now, is set of 2x plus 1. Now remember, okay, set of 2x plus 1 such that x is an element of integer. Is an element of integer. Now the next part is going to be the condition. Alright, so I've said that the set E is set of 2x plus 1 such that whatever thing x will be an element of integer. Now, and we are going to check the boundary. Now, for us now to check the boundary, we are going to take the whole of this in here. We are going to take this 2x plus 1 and equate it to the first number here, which is equal to -7. So find the value of x. S will be equal to -7 minus 1 all over 2, which is equal to -4. Very, very important. And now, so it means that it's going to range from -4 less than or equal to. Now, the next one now, the next number that's going to be here will still be take this 2x plus 1, equate it to this 3. Therefore, 2x plus 1 equal to 3. Now, therefore, x will be equal to 3 minus 1 all over 2, which is equal to 1. So, 1 here. Okay, so this is nothing but the boundary. So now this stuff which I have here is a kind of the range that will satisfy this condition. I've just said that putting this, of course, I have 3 set builder notations on which this can be represented. If you love the first one, go with it. If you want the second one or even the third one, they are all the same thing. But let me quickly re-explain the third one, alright? Because these 3 are the same, like I said. Let me re-explain the third. In the third one, it says that this x, whatever thing the value of x will be that will satisfy this condition, will range from -4 to 1. That is talking about the number line now. Because for instance, if this is my number line, and here is 0, here is 1, here is 1, 2, 3, here is minus 1, minus 2, minus 3, minus 4, minus 5, and so on. So now, this condition says that it ranges from minus 4 to 1. So it means that if I pick any number from minus 4 to 1 and plug it in here, I must have a number in this set. For instance, if I take s to be minus 4 and put it in here, you find out that 2 times minus 4 is nothing but minus 8, and minus 8 plus 1 is nothing but minus 7. Hence, I have this minus 7 here. Now, take minus 3 and put it in here. 2 times minus 3 gives me minus 6. Minus 6 plus 1 gives me minus 5. Alright? And of course, take s to be 1. If I put it in here, to be 2 times 1, which is nothing but 2 plus 1 gives me 3. And 3 is actually this one here. Alright? So, put minus 4 in here, you have minus 7. Put minus 3 in here, you have minus 5. Put minus 2 in here, you have minus 3. And put 1 in here, you have 1 again. Put 0 in here, you have 1. Put 1 in here, you have 3. So this is it. So is it that whichever one you wish to go with, is go with it. So these 3 are the set builder notation that attempts to represent this set in the listing method. Okay, the next question we are going to see says that should be our last question, which is question number 6. It says, write the set of positive perfect square. Write the set of positive perfect square number that is less than 120. Okay. The set of positive perfect square number that is less than 120. Okay, let me call that set. Let me call it set R. Now, of course, write it in both notation. Write it in both notation. We are going to have this. The set of positive perfect square numbers. So 1 is a perfect square, comma. Now, because 1 squared is 1, then 2 squared is 4, then next one, which is 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. Okay, the set is going to end here because the question said write the set of positive perfect squares that is less than 120. So these are the positive perfect squares that is less than 120, because if I had said 11 squared, I would have gotten 121, and 121 is greater than 120, or we want the ones that are less than 120. So that is why we are going to end at 100. So this you see here is nothing but the set of perfect square numbers that is less than 120. And of course, all these numbers are all perfect square because their square roots exist. Alright, if you take the square root of any of this number, it's going to give you a whole number, but not a fraction or a decimal. Now, again, putting this number, now taking this set R, putting it in the set builder notation, we are going to have that it is x squared. We're going to say that set R is set of x, or rather set of s squared, such that x is an element of the natural number. But it's very important we know what we're talking about. So that R is set of s squared rather, such that x is an element of natural number. Alright, but we're going to give the range. Remember that the natural numbers that give us these things are actually natural number from 1 to 10. Because this is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, and 10 squared. Therefore, we're going to say that it ranges from 1 less than or equal to x, such that s is less than or equal to 10. So this is the condition. This is the range of natural number, that is from 1 to 10. Or these are the values of s, such that when you square them, you have these numbers. Alright, so this is it. So these are the 10, or really 10, no? Okay, these are the 5 questions that attempt to explain sets in both notation. That is the set building notation and the listing method. And of course, in all of these things we've seen, you will agree with me that the listing method is a little bit simpler compared to the set builder notation. But the set builder notation, even though it's a kind of tricky or a little bit difficult, it is still better because this set builder notation will attempt to accommodate a whole number of sets when you, unlike the listing method, because in the case of the listing method, if you have a large set of number, it will be impossible for you to accommodate all of them. But if it is set building method, you can just represent them in words or in sets, or using mathematical operations like this. Alright, so this is it for this video. Thank you for staying tuned to this end. I appreciate you guys. So please do well to click on that red subscription button and turn on the notification bell so that you will be notified whenever I upload a new video. Alright, thank you so much.